Today we are going to solve practice problem 3.12 from Alexander Sadiku's Fundamentals of Electric Circuit 5th edition. Okay, so this is a transistor circuit. Here with the help of this arrowhead we know that it is a NPN transistor. Okay, so this shows that it is an NPN transistor. So here this is your input side. So we can form an input side loop, and this is your output side, so another loop can be formed here. So we can write the loop equations in order to solve and determine the values of V0 and VCE. So for that, the data given are beta equal to 100 and VB equal to 0.7 volts. Okay, so we are going to solve the problem now and we'll verify the answer back. So this is our circuit. As I have already told you, this is our input loop. At the input side, we are going to apply the KVL, Kirchhoff's voltage law. So it starts here and it is flowing like this, okay, and it ends here. So it is minus 5 volts. Then here, when it moves from here to here, it is plus, this is minus. And here also it is plus and minus. Another thing you should know that this is your base point for this transistor and this is your emitter and this is your collector. Okay, so the current which is flowing through this will be taken as base current, it is IB. Similarly, the current which is flowing through this particular resistance will be taken as IG current. Okay, so now we can write the voltage equations. Here it is minus 5, then it is plus 10 kilo ohm, right? So 10 into 10 power 3 multiplied by this IB current, then this voltage drop is existing here, this VBE. So it is plus VBE, and then across this resistor have the voltage drop of, so that is equal to 0. So what it is minus 5 plus 10 power 4 IB. VB is already given as 0.7 volts plus this VE can be written as IE into RE, that is equal to 0. So this is nothing but your V naught, right, which is asked in the problem. Both are same. And according to the current equation of this transistor, we know that this IE is the summation of IB current and the collector current, base current and the collector current. And this IC and IB are related as beta times IB. Okay, beta times IB. So that here I'm going to write this as minus 5 plus 0.7. These two are combined. So you get the answer as minus 4.3 plus 10 power 4 IB plus this IE current. We don't know about it. Anyhow, we can write it as IB plus IC, or we can write it as IB plus beta times IB, isn't it? Because IC is beta times IB. Instead of this IE, I have substituted this relation, okay, into RE. RE is how much? It is 200. That is equal to 0. So it is minus 4.3 plus 10 power 4 IB base current plus this beta is given in the problem as 100. So we can substitute this value as 100. So 100 IB plus IB, it is 101 IB multiplied by this 200, that is equal to 0. So it is minus 4.3 plus 10 power 4 IB plus 200 into 101. So it is plus 20,200 IB, that is equal to, so we can add these two IBs together. So it is minus 4.3 plus this is 10,000, this is 20,200 So in total you get it as 30,200 IB. That is equal to 0. 30,200 IB is equal to 4.3. IB is equal to 4.3 divided by 30,200. So for that we get the answer as 0.000142. So this much amperes we get. Okay, and this can be now written as is equal to 142.3 microamps. Once you get this IB value, you can go for finding this IE value. IE is equal to 101 times IB. Why? Because we know already that IE is equal to IB plus IC, and this is IB plus beta times IB, right? And this is IB plus 100 times IB, because beta is given. So it is 101 times IB, isn't it? So in that, if you substitute 101 into 142.3 microamps, that is 10 power minus 6. So the answer is 0.1437, this much amperes. IE is equal to 143.7 milliamps. Then we can find out this V naught, because this V naught and VE are the same, which is equal to IE into RE. This is the voltage drop across this RE resistance. So that is equal to 143.7 into 10 power minus 3, because it is milliamps, right, into 200, equal to 2.874 volts. So this is the first answer we got, right? V naught. Applying this Kirchhoff's voltage law at the output side. Okay, so it is minus 12. When you start from here, it is minus 12 plus 500 into this IC. So it is plus VCE, then this plus V naught or VE. Okay, that is equal to 0. This, what are all the things we know already? We know this IC already, we know this VE. VE is nothing but V naught, right? So I'm going to replace all these things. 500 into beta times IB. This IC is replaced by beta times IB plus VCE plus V naught, that is equal to 0. So it is minus 12 plus 500 into beta is 100 into what is our IB? 142.3 microamps. So it is 10 power minus 6 plus VCE plus what is your V naught? It is 2.874. That is your V naught, right? That is equal to 0. So the unknown value VCE can be determined now, because all of the values are being substituted. So when you add these two, you get it as minus 9.126 plus, so this gives you the value as 7.115 plus VCE is equal to 0. That gives you the value as minus 2.011 plus VCE, that is equal to 0. So we can write this as VCE as 2.011 volt. So now we'll verify our answers with the answers given in the book. Small differences there, okay? That's okay. Thank you.